Hi guys, welcome to my channel. In this video, I will be covering complete unit 2 in DevOps subject. I will explain all these topics in detail. I will explain DevOps and achieving business agility, continuous testing in DevOps, monolithic architecture, microservices architecture, and as well as architecture rules of thumb in DevOps, separation of concerns in software architecture, handling database migrations, and as well as I will explain resilience in DevOps, and also I will explain impact of DevOps on software quality and reliability, relationship between DevOps and software architecture, and how well-designed architecture supports DevOps principles. I will explain all these topics in detail, and whatever the topics that I am going to cover in this video, I will provide all those topics and the timings in description. Before starting this video, please check in description. Guys, I will provide complete unit 2 study material link in description. You can download from description. Guys, I have uploaded complete DevOps subject tutorials. I will provide that link in description. You can watch from there. If you are watching this video for the first time, don't forget to like, share and subscribe to my channel. Let's get started. At first I will explain impact of DevOps on achieving business agility. Guys, meaning of agility is ability to move quickly and easily. And whereas business agility means a company can easily adjust to market changes by being flexible and quick to adapt. Guys, for example, if you consider Samsung company, long back Samsung company produced normal smartphones, and after few years Samsung company produced 2G mobiles, and then 3G mobiles, and then 4G mobiles. Now Samsung company bought 5G mobiles. So based on user requirements, Samsung company immediately launched new smartphones. So here Samsung company easily adjusted to market changes by being flexible and quickly adapted to new features. So any company that can easily adjust to market changes by being flexible and quick to adapt is known as business agility. So by using DevOps, any company can achieve business agility. That is nothing but any company can easily adjust to market changes by being flexible and quick to adapt. As we know, in DevOps, development team and operations team will work together. And here in DevOps, they will use various kinds of automation tools. By using various kinds of automation tools, they will automate complete tasks. And they will keep on updating same software frequently. So whenever any customer want new feature in that particular software, then immediately customer will respond to that company, and then by using various kinds of automation tools, immediately company will update that particular software. So by using DevOps, companies can reach faster to changes in market. So how DevOps helps to achieve business agility means by using various kinds of automation tools, DevOps helps to achieve business agility. Guys, I will give one simple example. Guys, for example, one company is not following DevOps. As we know, in company there will be development team and there will be operations team. Duty of development team is to write code, and duty of operations team is to place that code in server. If company don't follow DevOps, that means, so if company don't use any kind of automation tools, after developers writing code, then it will take a lot of time to place that code in server. For example, customer gave project to this developer written code, and then developer submitted this code to operations team, then operations team placed this code in server, and after few days, customer said to update the same software again, but it will take a lot of time because this company is not following DevOps. That is, this company is not using any kind of automation tools. For example, now the same company is using DevOps. Whenever customer said to update the same software with new feature, immediately developer will start writing code, and immediately by using various kinds of automation tools, testing is done for this particular code, and then automatically without human intervention, this code is placed in server. So here DevOps will use various kinds of automation tools in order to complete work very fast. So with DevOps, they implemented automated systems. That is nothing but they are using various kinds of automation tools that allows developers to send their code straight to deployment. That is nothing but our code is directly placed in server. So this means new features and updates can reach customers much faster and able to adapt quickly to customer feedbacks. So whenever customer give new feedback, immediately they will update that code. These are various kinds of companies that are using DevOps in order to achieve business agility. And the first company is Amazon. As we know, in Amazon daily they will launch various kinds of products. Guys, e-commerce platforms are nothing but online shopping sites. For example, Amazon.in. So by using DevOps, new updates and features are automatically placed in Amazon.in. Guys, for example, in festival seasons, millions of people will do shopping in Amazon. So by using various kinds of DevOps tools, they will smoothly handle increased traffic and also transactions. Next company is Netflix. Netflix also depends on DevOps to continuously enhance their streaming services, like they will launch movies, web series, so on, and this is done by using DevOps. And third company is Google. Google always focus on working together and they know clearly about what is happening. So even Google also use various kinds of automation tools in order to check errors in the code and quickly deploy updates. Next company is Microsoft. Even Microsoft also use DevOps tools. For example, if you consider Microsoft products like MS Office, Windows, so on, to update these products frequently, Microsoft will use various kinds of DevOps tools. So while releasing these updates, they also focus on user feedback and as well as security. And last company is Adobe. For example, if you consider Adobe products like Photoshop, Illustrator, while creating these creative softwares, they use DevOps. Next, I will explain continuous testing in DevOps. In DevOps, continuous testing means testing your software non-stop from the moment you start writing it to until it is ready to place in a server. Guys, whenever you develop any code, we need to perform various kinds of testings after writing code. In DevOps, all these testings are performed automatically by using various kinds of tools. So it's about automating tests, so they run automatically whenever there is a change. Helps to catch bugs early and ensure the software works well. As for example, I created college website. In this college website, initially I created only student login form and faculty login form. After conducting various kinds of testing successfully, I placed this website in server. For example, now I want to update this same website with new feature. Like for example, now I want to add student attendance and faculty attendance in this website. So again I written code for this. So whenever you make any changes in the software, again you need to perform various kinds of testings. So in DevOps, continuous testing is nothing but whenever you perform any changes to existing software, automatically by using various kinds of testing tools, testings are performed. So for these two features, again testing is performed. For example, again I want to update this website by adding student result. So I updated this code. After updating code, again I need to perform testing. So this is continuous process. For example, while I am performing automation test, I got to know that this student login form is not working well. So immediately again we can update this student login form and again we can perform testing. So by using automated testing, we can easily catch bugs early so that software will work well. Guys, in software development lifecycle, we need to perform various kinds of testings, starting when developer writes code to until before placing that code in server. In between this, we need to perform various kinds of testings. So in DevOps, continuous testing means testing your code non-stop from the moment when you start writing it to until it is ready to place in a server. It's about automating tests, so they run automatically whenever there is a change. Helps to catch bugs early and ensure software works well. So whenever developer update new code in that particular software, automatically testing is performed. Guys, there are various kinds of testings in this continuous testing. And the first one is unit test. Testing each piece of code separately to make sure it functions correctly. Guys, unit test is nothing but testing each part of code separately. For example, I am developing college website. In that college website, I written code for student login form. I written code for faculty login form. I written code for student attendance form. I written code for faculty attendance form. So testing each piece of code separately is known as unit test. Second one is integration testing. Integration testing makes sure that all the different pieces of the software fit together properly and works well together. Guys, as we know, in software company, in order to develop entire software, only single developer will not write entire code. One piece of code is written by one developer and next piece of code is written by another developer. So at last what they will do is, they will combine all this code. So after combining all this code, again they will perform testing. This is known as integration testing. Next one is functional testing. Functional testing ensures that the software features and functions behave as expected. As for example, in the student login form, we will enter username and password. But due to some error in this code, whatever the password that I enter, automatically it will open this website. So there is problem with this functionality. So we need to test functionality of each feature. So functional testing ensures that software features and functions behave as expected. Next one is regression testing. Regression testing confirms that new changes haven't broke existing feature. Because for example, initially I created a website. That website contained only student login form and faculty login form. Later on, I updated the same website by adding student results. So even though if we add new feature, existing features must work well. So regression testing ensures that new changes haven't broke existing features. And fifth one is performance testing. Performance testing ensures that how well the software performs under different conditions such as high user load. Guys, for example, in the software, student login form is working well, but at a time whenever 1000 users access this website, the student login form is not responding properly. So we need to check performance of our software. Our software must work on different conditions. And last one is security testing. So whenever we develop any software, after developing software, we'll give that software to hackers. So hacker will hack that software. If there is any weakness in our software, automatically hacker can hack that software. So security testing checks the software for any weakness and make sure that sensitive data is protected. Guys, these are various kinds of tools that we use in DevOps in order to perform various kinds of testings. By using tools like JUnit and TestNG, we can perform unit test, and by using tools like Selenium and Cypress, we can perform functional test. By using Jenkins and Travis CI, we can perform continuous automation and integration testing, and by using tools like JMeter and Gatling, we can perform performance testing. By using tools like OWASP and Nessus, we can perform security testing. These are the challenges that we need to face while we perform continuous testing in DevOps. And the first one is automation complexity. We need to perform various kinds of automation testing in various platforms. So it is time consuming. And second one is tool integration. Guys, we need to integrate testing tools with DevOps tools. It is very tough. And third one is test data management. In order to perform various kinds of testing on particular data, at first we need to store the data in particular place. Managing this data in order to perform testing is very tough. So ensuring the availability and manageability of test data for various scenarios and environments can be difficult. Guys, these are various kinds of benefits if we perform automation testing in DevOps. First one is early bug detection. We can easily find errors in early stage. And second one is faster feedback loops. So after performing testing, if anything is not working well, immediately they will take feedback and they will develop new code again. And third one is improved release confidence. If each and every test is successful, then we will get confidence and then we can easily release our software. Fourth one is cost and time saving. By performing various kinds of testings, we can easily find errors and we can easily fix that errors. So it will save cost and time. And last one is collaboration between development, testing and operations team. In DevOps, development team, testing team and operations team, all these teams will communicate each other and they will complete work. These are various kinds of benefits if you perform continuous testing in DevOps. Next I will explain monolithic architecture in DevOps. Monolithic architecture in DevOps refers to a traditional software design where all components of an application like front end, back end and database, all these are tightly integrated into a single code base, which means everything is kept together within a single folder. Guys, I will give one example so that you can clearly understand this definition. Guys, any application contains front end, back end and as well as database. For example, I am creating college application. In that college application, total I created 4 pages. One page is student login form, next one is faculty login form, next one is student attendance and next page contains student results. So in college website, whatever you see, we consider it as front end. So basically I created this front end application by using HTML and CSS. In student results page, whenever I enter my roll number and click on submit, automatically I can see my results. How it happened? Because in backend, I written some code by using programming language like Python, Java, C++. I written some kind of code. So whenever I enter my roll number and click on submit, automatically I can see my results. So in backend, we'll write some kind of code. Based on that, our application will work. And complete data related to this college application like student names, student results, student attendance, complete information is stored in database. So database is used to store information. Whenever you develop any application, if we store code related to front end, back end and as well as database in one place, then we call it as monolithic architecture. For example, I created college application. In that college application, I stored code related to front end, back end and as well as database in one single folder. Then we call it as monolithic architecture. The name itself says Monolithic means single block, that is storing all these components in one single place. Monolithic architecture in DevOps refers to a traditional software design where all components of an application like front end, back end, and as well as database, all these are tightly integrated into a single code base. Single code base is nothing but storing all these components in one single folder. This is known as monolithic architecture. This is diagram of monolithic architecture. Single code base is nothing but storing all these components in single folder or directory. Total there are three components. They are front end, back end, and as well as database. Front end is nothing but user interface. We can create front end by using HTML and CSS. We call this front end as presentation layer. And next one is back end. Basically this back end contains business logic. In back end, we'll write code by using various programming languages like Java, Python, .NET, so on. So we call this back end as application layer. And third component is database. Database will store complete data related to application. So we call this database as data access layer because we can access data. So these are three components. So we can also call this monolithic architecture as three-tier architecture. In monolithic architecture, front end, that is user interface, and back end, that is business logic, and as well as data access layer, that is database, works as a single unit. So it is easier to manage all operations because all components of the software located in one place. As all these three components are located in one place, we can easily perform various operations. For example, I want to get student results. So whenever I enter my roll number in front end, automatically I can see my result. So we can easily manage various operations. In a monolithic architecture, changes made in one layer can affect other layers because they are tightly integrated. Guys, I will give one example. Guys, for example, I created college application. In this college application, I want to add new feature like I want to add new course page. For example, in this course page, whenever I click on CSC button, automatically it should display all subjects related to CSC. So again, I need to write code in backend by using programming language like Python, Java, so on. And again, I need to connect this course page to database. So in monolithic architecture, whenever you change one layer, then you need to change remaining layers too. And there is also another problem in monolithic architecture, that is, for example, if one layer is not working properly, automatically it will affect other layers. For example, due to some error, this backend is not working properly. So whenever I enter my roll number and click on submit, it will not show my results because this backend is not working properly. So if there is problem in one layer, automatically it will affect remaining layers. This is because in monolithic architecture, all these components are tightly integrated into a single code base. For example, I created a college website. In that college website, I want to add a new feature like adding new courses. So whenever I change presentation layer, I need to change business logic layer and as well as data access layer too. Next, I will explain advantages of monolithic architecture. As we know, in monolithic architecture, everything is stored in one place. So develop, test and deploy becomes easy and communication between these components is very fast. As all components are tightly integrated, developers can easily understand entire application. In monolithic architecture, deploying application is very fast when compared to microservice architecture. Next, I will explain what is this microservice architecture. These are disadvantages in monolithic architecture. First one is, it's challenging to update existing ones as the entire application need to be modified. Guys, I will give an example. Guys, this is college application which I created by using this monolithic architecture. Guys, for example, in this college application, I did one small spelling mistake. Like in login, I did not written I, just I written LOGN. So due to some spelling mistake, I need to change only front end. But as we know, front end, back end and database is stored in one place. So for this small change, again I need to place this complete code in GitHub and then I need to perform build and test operations for this entire application. I cannot perform build and test operations only for this front end. So I need to perform build and test operation for all these components. So it is challenging to update existing ones as the entire application need to be modified. And second one is, a fault in one part of application can bring down entire system since everything is tightly coupled. As I already said before, if there is fault in one layer, it will automatically affect remaining layers. And third one is, as everything is tightly coupled, it is difficult for teams to work independently, leading to coordination challenges. As complete code is stored in one place, then coordination between team is very tough. So this monolithic architecture is not suitable for large size applications. Just it is suitable only for small size applications. This is all about monolithic architecture. Next I will explain what is microservice architecture in DevOps. If you consider monolithic architecture, in monolithic architecture, entire application is placed in one single folder. So changes made to one component will affect other components. But whereas in microservice architecture, your application is placed in bunch of folders. Each folder is responsible for specific function. So changes made in one folder will not affect other folders. Guys, I will give one example so that you can clearly understand what is this microservice architecture. If you consider monolithic architecture, in monolithic architecture, front end, back end and as well as database, all these components are stored in one single folder and they are integrated to each other. But whereas if you consider microservice architecture, in microservice architecture, each service is placed in one folder and they are not integrated to each other. As you know, there will be three components: front end, back end and as well as database. In front end, I created student login form, faculty login form and as well as student attendance. So this application contains total 3 pages. For example, whenever I enter my username and password, automatically I must log in into that website. So I integrated the student login form with Java code, similarly faculty login with Python code and as well as student attendance with C++ code. And I connected the student login form with separate database and as well as faculty login form with separate database and as well as student attendance with separate database. Now what I will do is, I will consider the student login form as one service and I will place this entire code in one folder. Similarly, I will consider faculty login as another service and I will place this entire code in one folder. And similarly, I will consider student attendance as one service and I will place this entire code in one folder. And these folders are not integrated to each other. So whenever I perform changes in one folder, it will not affect other folders. So whenever I perform changes in one service, it will not affect other service. For example, in student login form, I written some spelling mistake. So whenever I perform changes, it will not affect remaining folders as all these folders are not integrated to each other. For example, due to some problem in database, I cannot access student attendance. Even though if you cannot access student attendance, you can access student login form and faculty login form because all these services are placed in different folders and they are not integrated to each other. So changes made in one folder will not affect other folders and also errors in one folder will not affect other folders. This is microservice architecture. First, in front end there will be user interface and there will be multiple microservices. Each service is connected to separate database. I already explained this example. In a college website, each function like student attendance, faculty attendance, student results and college courses, all these are considered as separate services in a microservice architecture. Changes made to one service such as updating the student attendance feature won't affect the other services like faculty attendance, student results and so on. Changes made to one service will not affect other services. So this is definition. If you consider monolithic architecture, in monolithic architecture, entire application is placed in one single folder. So changes made to one component will affect other components. But whereas in microservices architecture, your application is placed in bunch of folders. Each folder is responsible for specific function. So changes made in one folder will not affect other folders. In DevOps environment, microservices architecture shines because it allows for better scalability, flexibility and faster deployment and as well as resilience. These are 4 advantages in microservice architecture. First one is scalability. Scalability is nothing but modifying one part of application will not affect other parts, such as updating student results form will not affect student attendance form and faculty attendance form. Similarly, next one is flexibility. Flexibility is nothing but teams can choose the best tools and technologies for each microservice, making it easy to adapt changing requirements. Based on user requirements, developers can update code which is present in various folders and they can easily update specific part of code because changes made in one part will not affect other parts. So they can easily modify application based on requirements. And next one is faster deployment. As we know, each microservice is independent. So you can easily update only that part of application without affecting entire application. And last advantage is resilience. If one microservice fails, it does not bring down the entire application. the rest can still function normally. For example, this faculty login is not working well. So even though if this faculty login is not working well, it will not affect student login and student attendance. This both will work normally. These are disadvantages in microservice architecture. First one is complexity. Whereas in monolithic architecture, complete data is stored in one place. So it is easy to manage application. But whereas in microservice architecture, there will be multiple microservices in different folders. So it is very hard to manage. And next one is communication. If you want to develop any application by using microservice architecture, then all employees must communicate each other efficiently. Otherwise, you cannot design good application. And third one is monitoring and debugging. As we know, each microservice is stored in one particular location. So monitoring that application and as well as finding errors in that application is very tough. These are disadvantages in microservice architecture. Next, I will explain architectural rules of thumb in DevOps. Guys, rules of thumbs are nothing but they are generally principles or guidelines widely used in a specific area. They are not strict rules, moreover like a practical suggestions to achieve positive results in system design and implementation. Guys, if you want to achieve positive results in system design and implementation, then you need to follow these principles. I will explain all these principles in detail. These are not strict rules. These rules are just suggestions. So in DevOps architecture, if you want to do good system design, then you need to follow these principles. Another first one is modularity. If you want to design any system, then you need to design system in modular fashion. Modular fashion is nothing but breaking our entire software into smaller modules that works independently. Same like microservice architecture. So maintenance and update will become easier. And next one is scalability. Scalability is nothing but if you are designing any software, even though at a time 1000 people are accessing that application must run smoothly without sacrificing performance. Third one is automation. By using various kinds of automation tools, you can automate process like deployment, testing and monitoring application. So work will complete fast and will reduce human errors. Fourth one is resilience. Resilience means building systems that can handle failures by including backup plans and automatic switches. For example, whenever your software fails, then automatically it must take backup and then it must work properly. And fifth one is infrastructure as code. Managing infrastructures like setting to track changes, recreating setups and setup automatically. Sixth one is continuous integration and continuous deployment. In DevOps, by using tool like Jenkins, you can create pipeline in order to perform automatic continuous integration and continuous deployment. Seventh one is monitoring and logging. You need to create monitoring and logging systems in order to check system performance and detect issues early. Eighth one is security. Guys, you need to integrate security practices like encryption, access control, so on in early stage of development and deployment process. Ninth one is containerization. Guys, whenever you develop any application, we will not place our application directly into server. Instead, what we will do is, we will place our application in container and then we will place this container in server. So in order to place application in container, we will use tool like Docker. 10th one is feedback loop. Development team, operations team and as well as customers, they need to communicate each other and they need to take regular feedbacks so they can develop application better. Next I will explain impact of DevOps on software quality and reliability. Guys, by following DevOps principles, you can improve software quality and as well as reliability. Reliability means software that can automatically recover from failures and work accurately. This is meaning of reliability. Next I will explain relationship between DevOps and software architecture. Guys, DevOps and software architecture both are related to each other because by following DevOps principles, you can build a software architecture. Guys, in exam they may ask separate question like explain software architectures in DevOps. Then you need to explain monolithic architecture and microservices architecture. Next question is how well-designed architecture supports DevOps principles. Guys, if you want to design high-level software architecture, then definitely you need to follow DevOps principles. Guys, for all these three questions, you need to explain this answer. These are various DevOps principles: modularity, scalability, automation, resilience, infrastructure as a service, CI/CD monitoring and logging, security, containerization and feedback loop. You need to explain all these principles. Guys, principles and practices both are same. Next I will explain separation of concerns in software architecture. Separation of concerns means dividing entire program into various sections based on their functionalities so that Each section runs independently without affecting other services. Changes made in one section will not affect other sections. Guys, I will give an example so that you can clearly understand this definition. Guys, for example, I want to create college application. Let us say college application contains 4 pages: student login page, student results page, student attendance page, and as well as faculty details page. Total there are 4 pages. So instead of writing this complete code in one place, what I will do is, I will divide this complete code into 4 modules. First module contains code related to student login page, and whereas second module contains code related to student results page, third module contains code related to student attendance page, and whereas fourth module contains code related to faculty details page. I will show these 4 modules separately in different folders. So changes made in one module will not affect other modules. For example, I want to update the student results page. So without changing first module, third module and fourth module, directly I will open the second module and I will update code related to student results page. So changes made in one module will not affect other modules. For example, let us say the student attendance page is not working well. Even though student attendance page is not working well, remaining pages will work well because they are not related to each other. All are separated. So changes made in one module will not affect other modules. So separation of concerns mean dividing entire program into various sections based on their functionalities, so that each section runs independently without affecting other services. Changes made in one section will not affect other sections. Guys, separation of concerns will improve maintainability. Maintainability is nothing but updating specific part of code without updating entire code. And also it will improve scalability. Scalability means we can easily update new features to that particular software. And also it will improve readability. If we store complete code in one place, then it is very hard to read. But if we separate code into various sections, then it is very easy to understand because it will look very small. And fourth one is separation of concerns will improve debugging. As complete code is separated into various sections, we can easily find and fix errors. This is meaning of debugging. I already explained this example. Just you need to explain this college application example. These are some real world examples where separation of concerns is implemented. First one is modal view controller architecture. MVC is classic example of separation of concerns because it divides application into 3 components. First one is modal, next one is view, and next one is controller. Where modal will manage data and business logic, and view handles presentation layer, and whereas controller acts as interface, that is, controller acts as middle layer between modal and view. This controller will process inputs. Web applications are examples of modal view controller architecture. Next example is microservices architecture. As microservices architecture also follows separation of concerns because in microservice architecture, we will break our application into various parts based on the services, as each service will perform certain tasks. E-commerce websites and applications are example of microservice architecture. And third one is client server architecture. As client server architecture is divided into 2 main components, they are client and server. So this client server architecture is example of separation of concerns. Social media applications are example of client server architecture, and whereas last one is layered architecture. Separation of concerns is implemented in this layered architecture because this layered architecture will divide application into various layers like presentation layer, application layer, business logic layer, and data access layer. Each layer has separate role, like presentation layer will handle user interface, application layer will handle business logic layer will handle business rules and logic, and data access layer will handle database. So online banking system is example of this layered architecture. These are 4 real world examples where SOC is implemented. Next I will explain how to handle database migrations in DevOps. Guys, migration is nothing but transferring something from one place to another place. And whereas database migration means transferring data from one database to another database. This process can not only include just moving the data itself, but also transforming it to fit the new database schema, updating database structure, and ensuring data integrity and consistency throughout the migration. Guys, I will give one simple example so that you can clearly understand definition. Guys, database schema is nothing but overall structure of database. For example, let us say there is college database. In this college database, there will be student table, staff table, admin staff table, and student results table and courses table and so on. For example, the student table is connected to student results table and staff table is connected to admin staff table. So this overall structure of database like tables, columns and their connections, we call this entire structure as schema. Except data, remaining everything is known as schema. For example, I created new database with name my college and I modified some tables like I inserted new columns in student table, new columns in staff table, new columns in courses table and so on. So now I want to move data from college database to my college database. But transferring data from one database to another database is very tough. It is not an easy task. Whenever you transfer data from one database to another database, then this data must fit to this new database schema. Schema is nothing but structure. This data must fit to this new database structure. So database migration is not only moving data from one database to another database, but also whenever you transfer data from one database to another database, then the data must fit to new database schema. And ensuring data integrity and consistency throughout the migration. Guys, data integrity and consistency is nothing but correctness of data. Whenever you transfer data, the data must be correct. There must not be any loss of data. In DevOps, handling database migrations means managing the process of moving data from one database to another database, while ensuring it's done smoothly without any disturbance. This is important because changes to the database structure or data need to be matched with application updates to avoid errors. Guys, whenever you update database, updating database must not affect application. If you don't update database properly, then your application will not work. So you need to update database properly in order to avoid errors. In DevOps, we'll use various kinds of techniques in order to perform database migration. That is nothing but in order to transfer data from one database to another database. And the first technique is version control. Version control is nothing but Git software. One of the essential techniques for database migration in DevOps is use of version control for both application code and the database schema. Guys, whenever you develop any application, you need to store both application code and as well as database code in Git. After storing code in Git, you will create pipeline in order to perform continuous integration and continuous deployment. Whenever you create CI/CD pipeline in order to test and deploy software, in DevOps there are various kinds of tools like Liquid-based tool and Flyway tool. You need to connect these tools with CI/CD pipeline. Whenever you connect these tools with CI/CD pipeline, whenever you update database, then automatically it will update application code. Second technique is schema migration tools. Whenever you perform database migration in DevOps, you can use schema migration tools. Example of schema migration tools are SQL Server Data Tools and MySQL Workbench. These both tools are examples of schema migration tools. Whenever you want to update database schema, that is whenever you want to update database structure, instead of modifying complete SQL code, you can modify only specific changes without modifying complete code, and rest of the code is automatically updated by using schema migration tools. So schema migration tools are used to automate making and running SQL scripts. Instead of modifying complete code manually, you can modify only specific part of code without modifying complete code. Rest everything is automatically modified by using schema migration tools. Third one is data migration tools. Schema migration tools are used to modify only schema, that is structure of database. But if you want to transfer data from one database to another database, then you can use data migration tools. For example, sometimes there will be huge amount of data in database. Manually transferring data from one database to another database is very tough. So by using data migration tools, you can automate this process. You can easily transfer data from one database to another database. AWS data migration services and as well as Azure Data Factory. These both are examples of data migration tools. Even after performing database migration, you need to test your migrated database. Like you need to check performance test, security test and so on that particular migrated database. While testing, if there are any errors, you need to fix that errors. In order to perform testing on migrated database, you can use tools like SQL test and JMeter. This is all about handling database migrations in DevOps. Next I will explain resilience in DevOps. Resilience in DevOps means the ability of system to recover quickly from problems and continue working smoothly. It ensures that services remain available even when there are issues like failures or high traffic. Guys, I will give an example. Guys, for example, if you consider Amazon website, whenever you open Amazon website, it will be available to you. maximum Amazon website don't get any kind of problem. Even if Amazon website get any kind of problem, it can recover very quickly within short period of time. This is because of by following DevOps, Amazon achieved resilience. Another example is Google. Whenever you open Google search and as well as Gmail, they will be available to you. This is because Google achieved resilience by using DevOps. How organizations achieve resilience using DevOps? First one is DevOps support automation. In DevOps, each and every task is automated. Normally, human beings will not perform any kind of task. Automatically, system will perform various kinds of tasks. So, automate tasks like deployment and testing, reduce human errors and speed up recovery. So, even if any kind of error occurs, system will solve that problem instead of human beings. Second one is continuous integration and continuous deployment. Whenever developer updates small part of software, then automate testings will take place. So, it is very easy to find errors and solve those errors. So, regularly integrate and deploy small changes. Make it easier to find and fix issues quickly. Third one is monitoring and logging. Guys, logging is nothing but recording complete information about software. Recording each and every operation of software is known as logging. In DevOps, there are various kinds of tools available in order to continuously monitor particular software. So, these softwares will constantly check those problems so that we can easily identify issues and solve a problem. Fourth one is infrastructure as a code. Hardware, software, networks, servers, databases, all this comes under infrastructure. Guys, whenever you develop any software, then you need to set hardware, you need to set database, and you need to set servers. So instead of manually setting all those things, DevOps use automation. Based on the software, by using various kinds of automation tools, DevOps will configure hardware, software, servers, database, and so on. And fifth one is microservices architecture. Microservices architecture is nothing but breaking our application into various parts based on service. Instead of storing complete code in one place, what we will do is, we will break that application into various parts based on services. So even if one service fails, remaining services will work. And sixth one is regular backups and disaster recovery plans. Guys, backup is nothing but storing multiple copies of our data. So even if data loss occur, we can easily restore the data. And also we need to prepare various kinds of plans in order to recover from major failures. And seventh one is scalability. Scalability means designing system that will handle high load automatically. Guys, there are three popular companies using DevOps in order to build resilient architecture. And the first one is Netflix. Netflix use automation, continuous integration and deployment, and as well as microservices architecture. Netflix company use one tool called Kiosk Monkey. By using this Kiosk Monkey tool, Netflix wantedly tries to fail application and it will check whether application is causing failure or not. This is how Netflix built resilient architecture. And second one is Amazon. Amazon use automation and as well as infrastructure as a code and as well as scalability. Scalability is nothing but designing system to handle high load automatically. So even during high traffic periods, Amazon will be available to you. For example, if you consider festival seasons like Amazon Great Indian Festival, during that festival seasons, millions of people will access Amazon. Even during high traffic period, Amazon will be available to you. And third one is Google. Google utilizes monitoring, logging and as well as automated recovery. So that is why Google services like Google Search and as well as Gmail are highly available. These are three companies using DevOps for building resilient architecture.